Good afternoon and welcome to this webinar. Low GWP transition, making the shift to A2L refrigerants simple and safe. This event, brought to you by the ACHR News, is sponsored by Lennox. I'm your moderator, Kyle Gargaro, editorial director of the ACHR News. Thanks for joining us. Today's presenters are Eddie Chavez and Trent Davis from Lennox. Eddie has held various key roles with Lennox, including national account sales, operations, and product management. As the Director of Commercial Product Management, he is responsible for leading Lennox's unitary product strategy, including the low GWP transition. Trent is Director of Product Management and Marketing at Lennox Commercial. He previously served as Director of Heating Product Management at Lennox Residential HVAC, Director of Marketing for Allied Air Enterprises, and in several product management roles for heat pumps and air conditioners. He joined Lennox in 2013. Don't forget to submit your questions, and later in our program, our presenters will address as many as possible. Today's event is being recorded and archived on achrnews.com/webinars. And now it's time for today's presenters. Eddie and Trent, going to turn it over to you.
Thank you, Kyle. It's delighted to be here today to talk about the change coming over the next few months. So for those of you in the call, if you have not heard, there is a big change coming in new refrigerants for commercial HVAC. Today, we're going to focus around the impact it has around unitary equipment. And as most of you know, HVAC equipment has to transition to use these new refrigerants with lower environmental impact. But before we get started, I'd like to take a moment to just do a polling question and ask you, on a scale from 1 to 5, how prepared are you now to manage the HVAC refrigeration transition? So we'll open up a poll here. On a scale from 1 to 5, select the response where you feel, with 5 being the very well prepared, with 1 being not prepared at all. And as those responses start coming in, kind of gauge where we are. And then the hope here is by the end of this presentation, you'll be better prepared to make the transition smooth and seamless for you and for your customers. Good. So I do see some answers coming in here. It looks like 3 is the predominant answer here. So kind of most of the respondents, about 50%, are somewhat prepared for the transition. There are some that feel very well prepared, and there are some that are not prepared at all, which is okay. We're about 6 months away from when this goes into effect. I think that's where we're going to land. About half of you are on 3 here. So very good curve there. Well, let's get into the agenda and what we're going to cover. To do that, what I like to do is introduce Trent Davis, who is going to walk us through the first portion of the presentation, including the agenda. Then I'll come back to talk through some of the technical details and the changes coming with low GWP refrigerants.
All right. Thanks, Eddie. Appreciate it. Glad to hear everybody's engaged in this topic today. Very few of you feel fully prepared for this transition, and some of you feel like you know nothing at all. We're happy to help out today and give a little insight into what's happening in the broader industry. And we're going to start with the past. We're going to go to the HFCs of the past or the current, how we're going to phase those down and out over the years to come. Then we'll transition into talking about these new low GWP refrigerants. What is low GWP? What is the terminology? What do they mean? What makes a low GWP refrigerant different, not only in its chemical composition, but its practical application in commercial HVAC. And we'll talk about one of the elephants in the room, the topic of flammability when it comes to A2L refrigerants. That's one of the most significant changes, and we're going to talk to you in specifics about how manufacturers like Lennox are mitigating the risks of these refrigerants and incorporating safety into the design of new products. Next, we'll talk about sell-through rules. Every transition comes with a set of sell-through rules that governs what previously manufactured equipment can be legally sold and installed and for what period of time. So we'll make sure that you're fully equipped there and don't wind up with any unmet commitments or any stranded inventory. And then finally, we'll go through some frequently asked questions and give you the opportunity to type your questions in and have them answered live. So make sure to use the Q&A function today. As questions occur to you, submit them there, and we'll go through some of those at the end. And Kyle will walk us through and ask Eddie and I a few different questions along the way. So those are our topics for today. Looking forward to your engagement and hearing your questions later on. So let's start with the HFC phase down. And this is how we're going to transition out of R410A and other similar refrigerants that are in the market today. And one of the biggest questions I hear on this topic is, why is this transition happening? Why is it necessary? We just made a transition from R22 not too long ago. A lot of you in the call today probably remember that transition. So why are we doing this again? Well, the simple fact is that most refrigerant today ends up in the atmosphere. And we know that because the EPA, the United States Environmental Protection Agency, tracks statistics about the rate of refrigerant reclamation in the country. So refrigerant is considered reclaimed whenever it's recaptured into a cylinder and then returned to a certified reclaimer who reprocesses it to AHRI 700 standards. So according to the US EPA, less than 15% of the refrigerant that goes out into the market winds up getting reclaimed. And for the most recent year, the data is available. About 15 million pounds of refrigerant was reclaimed. That's mostly R22 and R410A, versus over 100 million pounds that went out into the market either in new equipment or as service gas. So when you look at that kind of delta, it's not hard to do the math. The remainder of those 85 million plus pounds wound up in the atmosphere. And regardless of your point of view on this, that's not a positive for the environment. And the EPA has a statutory mandate in order to reduce refrigerant emissions and their impact on the climate. So that's the why. And then a little bit of past history. I mean, some of you know, or many of you know, and some of you don't, was back in 2006, we made the transition from R22 refrigerant to R410A refrigerant. And the advantage of that was we moved to a non-ozone depleting refrigerant, and it also didn't include chlorine any longer. Now, at the end of 2024, we're in the process of transitioning to two new refrigerants, R454B and R32. And the purpose of that transition, as I just said, is to replace R410A with a refrigerant with lower global warming potential, which is also referred to as GWP. The basic math on this is that those new refrigerants reduce global warming potential by up to 78% versus R410A. So when you think about the global lawmaking, the federal lawmaking in the United States, work that's happening in Canada and other parts of North America, there is a long-term expected phase down of HFCs running out through about the year 2050. And the anticipated impact of that is a substantial decrease in carbon dioxide equivalent emissions. So if you wanted to translate that into something that's maybe a little more easy to get your mind around than 4.6 billion metric tons of carbon dioxide, I'll go back to my youth and my time when I grew up in Kentucky, and we had coal mines and we had coal power plants. And you see these coal trains running through town with loads of coal, like you see at the bottom there. That created a lot of emissions. And so when you look at that picture below, this is the emissions decrease equivalent of 25 million rail cars of coal being burned. So any way you cut it, this is going to make a significant impact on the environment to the positive as a result of this transition. So we talked about phase down. I wanted to show you in more specifics what exactly that phase down means. And what you may know is that R22 was also subject to a phase down. They established a baseline of allocations. That baseline established a level at which R22 could be imported into the country and sold. We actually have already begun the HFC phase down, which primarily affects R410A in our industry. We were actually at the 90% of that baseline back in 2022 and 2023. This year, or at the beginning of this year, we had another major step down. So we went from 90% of the baseline to 60% of the baseline. So that puts us at a net 40% reduction of HFCs. Now, you may have seen the impact at your local supply house. Refrigerant prices have generally gone up. Supply and demand, as supply becomes constrained by these regulations and demand remains the same or higher, we're going to see prices go up. So on one hand, this makes reclamation more important than ever, just from a pocketbook standpoint. But the other thing is, if you went through the R22 transition, you know how expensive R22 gas got. And that was a direct function of the limitations on allocations through a program like this. So if you look at the time frame here, there's a 60% step down here, then we'll go to 30. And then we're going to go on to the future at even lower and lower levels. And there's possibly even a future step down to lower GWP refrigerants out there. So the main takeaway here is you should expect R410A prices to rise for this foreseeable future. And it's more important than ever to reclaim these gases, not only for the environment, but also for the health of your own business and for all of us as an industry to have adequate gas available to service and maintain the existing R410A equipment that's deployed in the market. All right. So at the end of the 15-year period, you'll see an 85% phase down in HFC allocations, which will essentially put those refrigerants out of use and nearly unavailable. All right. So I've given you a little bit of background as to where we came from and why this transition is happening. And so I'm going to hand it back over to Eddie now so he can take us through an introduction to low GWP refrigerants, the terminology, the technology, and what it means for you. So Eddie, go ahead and take it away.
Thanks, Trent. Based on those results we saw earlier from the poll, about half of you are somewhat prepared for the transition. And so this introduction to low GWP refrigerants hopefully is just a refresher. And it may be something new for some of you out there. So a couple terms or three terms that I want to talk about today. We've already talked about them: HFC, GWP, and A2L. So let's talk about what these mean. HFCs, those are just refrigerants that are made up of hydrogen, fluorine, and carbon. As an example, R410A is an HFC refrigerant. That is where the HVAC industry is right now. And as Trent mentioned, with that phase down, we are transitioning to a different type of refrigerant. The goal here is to reduce global warming potential. And the way global warming potential is used is through a GWP metric. This metric is the equivalent of carbon dioxide. So, for example, carbon dioxide has a GWP factor of 1. And so if we take a look at different refrigerants, R410A has a GWP of over 2,000, so 2,088 to be exact. As we look at other refrigerants, that GWP will be lower, and we'll see it here shortly. But this introduces a challenge, which is A2L, and we'll talk about that A2L flammability. It's a safety classification that indicates both the flammability and the toxicity of a refrigerant. Both of the main refrigerants that are considered in the industry for the transition, R32 and 454B, are both classified as A2L refrigerants. So if we look here and compare the existing R410A of GWP of 2088, if we look at R454B and R32, both are below the 700 GWP threshold set out by the EPA. And so R454B has the lowest GWP of 466, while R32 has a GWP of 675. So again, both below that threshold, both meet the requirement. The formula is slightly different between the two. R454B is a blended refrigerant made up of roughly 70% R32 and roughly 30% of R1234YF, while R32 is just 100% R32. Both have the same classification of A2L. And this classification is laid out by ACHR. So ACHR Standard 34 has safety classes. And in the past, it was just A1 through A3 from a toxicity standpoint, of lower toxicity standpoint, and then B1 through B3 when it comes to higher toxicity. So that first digit indicates the toxicity level, that's CA, meaning it's got a lower level of toxicity. So the new refrigerants that are A2L have the same level of toxicity as R410A. Now, the second character indicates the flammability. And previously, you had flammability levels between 1, 2, and 3. So when these refrigerants, 454B and R32, started being studied and looked at flammability, a new classification or new class was introduced in between A1 and A2. This new class is a lower flammability, so it is lower than A2, but it's in between sort of A1 and A2 there. Same level of toxicity, and R454B remain in that A2L classification. We'll talk about how to mitigate the flammability here in a second. And so how do we manage it as an industry? How do we manage it on the product? And what are we doing to make it safe and simple? The answer is UL has a standard that the industry follows, and that is UL 60335-2-40. It defines the refrigerant detection systems and how OEMs implement those. In the equipment coming out next year, what you will see is that HVAC equipment will be equipped with the refrigeration detection systems, or RDSs. This system is composed of a sensor that will detect when a leak occurs on the equipment, as well as controls to initiate a mitigation action outlined by UL 60335. So as we go into what happens when a leak is detected, so here I'll walk you through in the event of a leak. The simple answer, what happens? It is mitigation. UL 60335 explains the sequence of operations to mitigate the refrigerant. So what's going to happen is, regardless of the unit's current state, whether it's idle, whether it's cooling, whether it's heating, the blower is going to turn on in the event a leak is detected. And this diagram shows kind of the steps that the unit takes. First, once a leak is detected, the blower will turn on. It doesn't matter if there's a call for cooling or a call for heating, the blower will automatically turn on and remain on. And if there's another call, whether it's for heating or cooling, it will not allow the unit to go into those calls. At the same time, an alarm is going to be triggered to alert that a leak has been detected and that the blower has been turned on. We do have within our product lineup the core control system, and other OEMs have other control systems in place. There is going to be an alarm contact, and we are going to send an alarm that will be available via BACnet that will support this notification. Once the blower is on, it will move the refrigerant from what would be a relatively small space and a packaged equipment into the space where it's a larger mechanical, or where there is more space to mitigate the refrigerant. The larger volume on this space versus a small space makes the mitigation so that there is no flammability in the space. So it's going to prevent the leak refrigerant from reaching what we call LFL, and it's going to reduce the chance of any ignition occurring here. So let's talk about what the different A2Ls mean as far as the mitigation in moving the air into the space. So when there is a A2L, as it's classified mildly flammable, there is a low burning velocity. And so we talked about R410A. Here we go. Okay, so we talked about R410A classified as an A1 refrigerant. The way it's classified is based on how the flame reaches, whether it's 45 degrees on each angle when it's ignited. So A1's R410A, very small flame, doesn't go past that 45 degree angle. When we get into A2s or A3s, A3, you see an example here, it's propane. It ignites in a much faster flame. Well, the A2L just goes past that 45 degree. And that's the reason why we needed an A2L classification, because R454B and R32 didn't quite meet the A1 refrigerant. It went just slightly above that 45 degree. And that's where the A2L refrigerant classification was created. So mildly flammable, and it's only flammable when it's in high concentrations. So by mitigating the refrigerant into a larger space, that removes the opportunity or chances of that refrigerant catching fire. So or igniting. So let's take a look at a real life example here of an application. So when we have, first we talked about LFL, and what is LFL? So to put flammability and LFL sort of in this different perspective, When we look at 454B, the LFL of 454B is 11.3%. And so if we look at an application, let's take a look at a conference room, right? A 20 by 15 conference room. In order to have a typical conference room and get that LFL level, we would of 11.3, we would need the equivalent of 57 pounds of R454B refrigerant in the space. That is a lot of refrigerant in that space. The maximum charge of an R454B in that same conference room is the equivalent of 20 pounds. And furthermore, if you look at the typical capacity calculation for this size room, in reality, you only need under 20 pounds or 2 tons to cool this room. So the risk that you're going to have 57 pounds in this conference room are very, very minimal. Both are below the ACHR minimum, and it makes it a little bit safer. So just an unplausible scenario here. Let's say for any reason, a 50-ton gas unit was installed to cool this small conference room. Keep in mind, there's only a 2-ton load in this conference room. Let's suppose that the unit, it releases all of its refrigerant all at once into the space. That would be 38 pounds below the LFL of 11.3. And so here, really the takeaway is mitigation is the solution to solving the flammability issue. It is the safest strategy. It is outlined by UL 60335, and all the different OEMs have included some sort of sensors, some sort of controls to make sure that the equipment, as it's installed in these spaces and as a mitigation happens in the event of a leak, is a safe strategy as far as mitigating the refrigerant and making sure there is no high concentration there. So we do have 410A equipment that we are still building as an industry. And for that, what we've done is we're going to go through, and Trent's going to talk through the sell-through rules and what it means over the next couple of years as we work through the R410A equipment.
All right. Thanks so much, Eddie. So one of the practical considerations with transitions like this is how long can I sell the equipment that is currently in my stock if I'm a distributor? Can I meet the commitment to my customer who I specified a product into the job? And when should you stop specifying products into jobs because you don't know if you'll be able to get the equipment or not? So sell-through rules help us understand a lot about how much runway you'll have to continue selling R410A based equipment after the manufacturing transition cuts in. So first thing you should know is the EPA understands this challenge for the industry, and Lennox and other OEMs in the industry, along with distributors and trade associations, really rallied to make sure that we had an adequate sell-through period in order to be able to sell through the existing equipment and ensure we didn't have stranded inventory. So sell-through rules in this case would mean the sale and installation of equipment. So manufacturers like us can no longer manufacture products using a higher GWP refrigerant as of January 1st, 2025, but inventory that's already out there and produced prior to that date is allowed to be sold through for a period of time. Now, we're going to take a little bit of a detour into regulatory terminology here, so bear with me, but it's important to understand the strict definitions around these terms so that you stay on the right side of the regulation. Under this sell-through rule, products are segmented into 3 different categories, or units are segmented into 3 different categories. One is called products, another is called systems, and there's a third category called components, which is sort of new to our industry. I'll explain each in the sell-through period that's attached. So being that we're talking about commercial here today, we'll start with rooftop units or packaged units. And these under the law are classified as products. And now I know what you're thinking, a split system is also a product. Well, okay, in the popular vernacular, it's true, but in the course of this regulation, the term product has a very specific definition. And for all intents and purposes, what it means is a unit that is fully manufactured, sealed, and charged with refrigerant from the factory. So that's the definition of a product in this category. Those products that come from the factory with refrigerant already inside them, already set to operate, have a 3-year sell-through period. So if someone manufactures an R410A rooftop unit on December 31st, 2024, that unit can be sold and installed until December 31st, 2027. Now, again, a manufacturer like Lennox can't produce new units once 2025 rolls around, but what's in inventory can be sold. And to be clear, this regulation is about the U.S. specifically. This is about the EPA's realm of control, which is the United States. Some examples there, you see rooftop units. If you're familiar with the Lennox line, our Model L, Enlight, Zion, Raider, and other similar packaged rooftop units would fall under the 3-year sell-through rule. All right, so that's products, 3 years for products. The next one is a term called systems. And a system is 2 units or more that are assembled and charged in the field by connecting multiple components together. So this is like your traditional small splits or large split systems. So these units have a 1-year sell-through attached. So again, if you make a R410A 5-ton heat pump in December of 2025, or excuse me, December of 2024, that product can be legally sold for 1 year up until New Year's Eve of 2025. It's also true of large splits as well. So generally speaking, those are products like the ELXP, ML18, and so forth, if you're familiar with the Lennox line. There's another category I mentioned to you that's new, and this is called components. And it's on this slide because it's hard to tell a component versus a unit that goes into a system without checking the certification label. Components address a concern about how you maintain existing systems that may have one half of the system fail. So let's say you have an air handler and a heat pump installed in the commercial space, and after 8 years, the air handler has to be replaced. Well, R454B and R32 products are not backwards compatible. So rather than forcing you to replace the entire system, the EPA has allowed for something called a component, which is a newly manufactured unit that's marked strictly for repair that uses R410A refrigerant that can be used to repair an existing system. Now, the clever folks among you might be thinking about workarounds and loopholes here. It's explicitly illegal to take 2 components that are marked for repair and combine them to make a new system. I think this is one of those things that Lennox can't support. Other OEMs are not going to support. Components are intended and designed strictly for repairing existing systems. So bottom line here is, if it's a product with a closed refrigerant circuit that's fully charged in the factory, that's generally a product. You have 3 years to sell it. If it's a split system, you're looking at a 1-year sell-through of R410A. And then components are able to be manufactured and installed indefinitely as long as they're used in repairing a current or existing system. All right, so if you have questions or curiosities about that, make sure to answer or submit your questions in the chat. Now, as I said earlier, these rules apply to the United States. And there's an interesting regulatory dynamic because a lot of the suppliers that manufacture equipment for sale in Canada are based in the US, and therefore we're subject to the law and regulations under EPA rules. But U.S. and Canadian law, Eddie, don't directly correlate on this. So there's a little bit of a difference in the timing and nature of the Canadian and U.S. regulations. Can you walk us through a little bit of the implications for our Canadian friends?
Absolutely. So let's take a look at some of the Canadian transition implications as the result of this transition here. And so we talked about the EPA technology transition rule, which is prohibiting the manufacturing of products with R410A refrigerants at the end of this year. So effective next year, we as OEMs and anyone as OEMs cannot build packaged equipment here in the U.S. As Trent described, there is the component part of it that will still be allowed for split systems, but packaged equipment is not able to be built after this year. Now, the components themselves are not backwards compatible. So compressors are different, expansion valves are different. So the plumbing system of an equipment is different between 410A and 454B. So you cannot swap refrigerants there. And so OEMs are planning on converting to low GWP refrigerants. But the risk here is that CSA B52, which is the equivalent of UL 60335, may not be adopted by the Canadian provinces in time by January 1st, 2025. And that is a risk that we are facing as an industry. So let's take a look at the current status and what we're doing going forward. So just from a history standpoint, at the national level, CSA B52, that mechanical code was updated at the end of last year. And now it's up to the individual provinces to adopt it to ensure that it's written into those building codes. Now, typically that would be a 2-year cycle, which would put the adoption in mid-2027. So that's kind of 2 years behind when OEMs are transitioning to the new low GWP refrigerant. Now, because of efforts from HRAI, which is the equivalent of AHRI in Canada, provinces have accelerated the adoption, this code adoption, and that timeline is varying depending on where the province is. So, quick update here. You see those provinces in green have already adopted low GWP into the building codes. Some of the main provinces are expected to adopt the CSA B52 and write it into their building codes, either summer or fall of 2024. But there's still a risk in the Alberta and BC provinces where adoption is expected to be either late 2024 or at the beginning, early of 2025. So there is still a gap there. Overall, provinces are making progress. There is still a risk for adoption there in those two provinces of BC and Alberta. I think there's a lot more to come here in the Canadian refrigerant transition. Lennox, as well as other OEMs, are working directly with HRAI and making every effort in supporting our Canadian friends to make sure that the transition goes smoothly for them as the U.S. And prepare for the EPA transition as outlined in the last 20 minutes or so. With that, what I like to do is take a little break here and start answering some of the questions that we've received. So we'll turn it over and do kind of a quick frequently asked questions. It was encouraging to see that about 50% of you, or about half of you, are somewhat prepared for the transition. What I will share the last few months, that's a question that I always ask, whether it's contractor, distributors, or engineers. And the answer has typically been more in the 1 to 2 range. So as an industry, our job here is to educate and make sure that we transition smoothly. But through all of this education, I'll answer a couple of questions first that we typically get asked. And I've got one here as more questions come in from the audience. So what does GWP mean, and what does that number indicate? Again, that's GWP is the global warming potential, and that's the metric to really assess the chemical's environmental impact relative to carbon dioxide. Again, CO2 has a GWP of 1, R410A has a GWP of 2088, and the refrigerants that we're looking for the transition must have a GWP below 700. That is R454B and R32 with lower than 700 GWP. Looking here for some other questions. I think what I'd like to do is turn it over to Kyle, and then we start taking some of the questions from the audience that we've been receiving over the last few minutes.
All right, yes, absolutely. Sounds good. Great presentation, Eddie and Trent. Really appreciate it. Like you said, we can get to some questions here. First one up is going to be natural refrigerants in 2034. Why not now?
Yeah. Eddie, I can jump in and take that one. So, as you all know, even with lower GWPs, these are still pretty potent greenhouse gases, right? A GWP of even 700 is still fairly high. It's 700 times more potent than carbon dioxide. There were some discussions and some pushes from some advocacy groups to move towards a lower GWP limit sooner. What we came upon here with this regulation was sort of a somewhat negotiated agreement among all concerned parties in the U.S. manufacturers, the contractors associations, environmental groups to determine what's the most rapid phase down that we could make in the GWP impact of refrigerants while still making it practically achievable and preserving the safety of homes and buildings. So I think what you're going to see, there's another question I saw submitted that I'll just go ahead and answer because it's tied in. Will there be another refrigerant change? And the answer to that is likely yes. So over time, I expect in about a decade, we'll likely revisit this topic, and you may see a move to either a 300 or a 150 upper limit, which is a pretty substantial progression. And the ideal within some quarters of the world is to move towards completely natural refrigerants like carbon dioxide or CO2 or things like propane or butane. You may know that certain home appliances like refrigerators use butane or other A3 type refrigerants today, just in very low concentrations. So I think we should expect continued change on this front. We'll probably get about 10 years of these refrigerants before you see major change considered in North America, and we expect that to come with it. So Eddie, anything you would add to that?
No, I think, Trent, you answered it correctly, and nothing else you add.
All right, another question for you here, Trent. Bernie's asking, A2L consists of HFCs, which are being phased down by the AIM Act. They consist of HFC 32, which is being phased down. Are they somehow exempt from the phase down?
Yeah, that's a great question, and you definitely noticed a key detail there. This was one of the big questions I had when I read the regulation myself, and which is thrilling, by the way. I highly recommend you all download the 200 pages and read it from the Federal Register. Anyway, joking aside, there were two considerations. One was, do we prescriptively ban refrigerants by name, so ban certain chemicals or certain chemical compositions, or do we ban all chemicals as they're used above a certain GWP level? And I think the situation is, if you tried to ban certain chemicals or refrigerants by name, you kind of have to think about how people would escape the regulation. It'd be possible to make very minor reformulations of existing refrigerants, so they wouldn't they wouldn't definitionally be banned, but they would still be higher GWP. And so you could imagine tweaking a formula by 0.1%, which would have no appreciable effect on performance, but might circumvent the regulation. So they felt like it was impossible to regulate and would leave a lot of loopholes open. So instead, they said our real goal is to reduce GWP, not to ban a class of chemicals. So instead, they decided to go for a 700 GWP application, which is what allows HFC 32, which is also known as R32, to remain in use as part of either as a pure refrigerant or as a blend. So that's good eye for detail there. That's a good question. Thanks.
No, thanks for the explanation. That was interesting there. I'm going to bring you in, Eddie, if you don't mind. How is
Sure.
GWP calculated?
So GWP is calculated in the impact it has when compared to carbon dioxide. In other words, how long does it hold on? Does it stay in the atmosphere? And it's really the measure of that global warming potential. It's measured against the impact of CO2 or carbon dioxide. I think we covered that there shortly a few minutes ago.
Next one up here.
The simple way to think about that, Eddie, the way I think about it, the simple way to think about it is it would take 700 times, if you have a GWP of 700, it would take 700 times more carbon dioxide to have the same greenhouse effect as a unit of that refrigerant, right? So moving from a 2088, meaning R410A is 2,000 times worse than carbon dioxide per unit, this is a pretty significant harm reduction versus the alternative.
Next one up is, how will this change affect VRF systems?
Eddie, you want to take that one?
Yeah, so VRF systems, I can take it, Trent. VRF systems they will get impacted as well, but they are under a different timeline. And so everything we've discussed here is impacting the unitary equipment, meaning split systems, packaged equipment. Ductless or VRF, it's about a year later. So similar timeline, similar impact, but it's coming into effect January 1st, 2026. You do see some OEMs already changing to A2L refrigerants or low GWP refrigerants in ductless or VRF equipment. The regulation for it is in January 1st, 2026.
Looks like maybe this one is for Trent. Is an evaporator coil that sits above the gas furnace considered a component?
Yeah, so the evaporator coils like that don't contain refrigerant from the factory, and so they essentially function as a repair component. For example, manufacturers don't have to phase out their 410A lines of coils and then launch brand new ones that are identical. And then I know Lennox specifically has sort of a transition model of coil available that you can buy a version of it and then choose which refrigerant goes in it at the time of installation. So yeah, coils can still function essentially as repair components.
And then Eddie, will components have different model numbers from current products, and can current products be installed as components going forward?
So Trent covered it a little bit. From a component standpoint, we're referring to split systems where you could have a condenser or you could have a coil, and both of those can be replaced indefinitely, right? As far as the model number, different OEMs may handle the model number differently. However, the EPA and the technology transition rule does identify certain labeling requirements for the equipment. And so when it comes to components, each one of those components, if it's manufactured after January 1st, 2025, will have to be labeled that this is a component used for service, and it's not intended to be used for new installation. So that's how we differentiate between components manufactured post the regulation timeframe of January 1st, 2025, and any sort of components that are built or left over as a result of the transition.
All right, going to keep you in the hot seat here, Eddie. Does this require variable drive blowers, and where does the blower vent the gas?
Yeah, so I think the EPA doesn't dictate the technology that has to be used in terms of blower, right? Most OEMs have moved to some sort of variable blower as a result of the DOE 2023 efficiency requirements that went into effect last year. And so the blower itself, as mentioned during the mitigation phase, the blower will turn on and start the mitigation process to move the refrigerant from that small enclosed space in a rooftop unit to the larger space that rooftop is serving. And that allows to bring that LFL lower flammability level down to provide a safer mitigation and dissipation of the refrigerant, minimizing any potential for ignition.
All right, Trent, I'm going to bring you in on kind of HVAC's version of the Coke versus Pepsi, I think. Why would one OEM choose to use R54B over R32 and vice versa?
Yeah, that's a great question. And, I think that I'll speak to our philosophy at Lennox. Okay. And I think this is probably similar to the philosophy at some other companies. We kind of have a format war on our hand, right? Depending on your age or your era, it could be Coke versus Pepsi. It could be VHS versus Beta. It could be Blu-ray versus HD-DVD. But I think the reality is different chemicals like this exist because they work well in certain applications. And so our design philosophy at Lennox has been, we'll select the right technology and the right tool for the right application. And I think there are spec sheet characteristics of these refrigerants, and you look at that and say, well, this one has larger capacity, or this one's more similar to this refrigerant. And on a spec sheet, I think, and in a lab, those are theoretically true. When you do real world testing, what we found was we experimented deeply with both refrigerants and found that in certain applications, you got some surprising results. So you might see one that theoretically had a higher capacity that didn't actually deliver that higher capacity in the applications where we use it. You can see certain, so R32, for example, has a higher discharge temp than R454B. In some applications, that's problematic. In others, it's not at all. In other cases, its higher capacity shows up, and sometimes it doesn't. So I think that what we've tried to do is pick the ones that perform the best for the applications that our customers need and apply them to the right product. you will see in our portfolio over the next couple of years, you'll see both refrigerants represented in the portfolio, and that will largely cut along the lines of, at least for Lennox, R454B will be more common in unitary type products like rooftop units and residential splits. And then on more ductless style products like mini splits and VRF, you're likely to see more R32. And another factor that factors into this is the experiences companies have. So if you'll look at the industry broadly, a lot of the more US-based companies or companies that have their legacy in the US seem to have gravitated towards R454B. A lot of the Asian manufacturers have been using R32 for several years in Asia, and so they were already familiar with it, and they followed that track too. So we're not here to pick one refrigerant as superior over the other. Fundamentally, I think you pick the right tool for the right job. And so you're going to see a mix of refrigerants in the market from different manufacturers and in different applications.
All right. Well, Trent, I've heard that question a lot, and that's the best answer I've heard so far. So I'm going to give you another one. This one's from Ryan. Do you think that these rules will ultimately push the market into using natural refrigerants like CO2?
Yeah, I think there's a lot of policymakers who would prefer that we go straight to natural refrigerants and all that. I think we all know there's technology limitations, there's application limitations that we had to be considered and solved first. With CO2, the challenge, it's a very low GWP refrigerant. It's 1, right? It is the lowest GWP refrigerant that exists. CO2 is. However, it requires extremely high pressures in order to operate, which creates not only durability and design challenges and efficiency challenges, but it also creates safety risk, both for installers and technicians and for people in the homes and buildings where it operates. So you've seen CO2 emerging in refrigeration, commercial and industrial refrigeration, and you'll continue to see that. I think we're a ways off from CO2 or propane in American homes and buildings. I think, though, over time, over the decades to come, you will see us move closer and closer to natural refrigerants as technology and codes allow.
Okay, going to bring you back in here, Eddie. This is a good one, but a little bit of a long one, so stick with me, please. For the installation process during construction, do we need to ensure the leak mitigation controls have been started up, commissioned? Moved on me.
Okay.
Started up, commissioned, and are working before filling lines with refrigerant? Will these controls need to be field tested or just certified from factory? Do you get that? And even repeat it.
So I think I've got it, Kyle. So I think the answer here, UL 60335, and that standard sort of dictates the refrigerant detection system as far as commissioning and the sort of the different faults. So the way it's outlined is the unit, once it's installed, when you think about a package equipment, the installation itself, there's not a lot of changes of the 410A equipment versus the 454B. The sensor itself will be initiated by the control. There is an initiation sequence of operation, and so it's all done by the controller. The sensor itself will check to ensure that it's calibrated, that it's operational, and there is no commissioning of the sensor itself. So once the rooftop unit is placed and once it is installed, the controller will start up the sensor, and once the sensor receives a signal, we should say communicating sensor, once the signal is received by the controller that it is active, it's operating normal, then the unit can start normal operation. There are, within the UL 60335 standard, in the event that the sensor does not respond or becomes inoperable for whatever reason, the unit will do an alarm and will start a sequence of mitigation there. And so the unit controller will check actively for that sensor to make sure it's operating correctly. It will not let the unit operate if there is a faulty sensor there. But no additional work from a commissioning standpoint to start up that sensor on the package equipment. So I think I answered part of the question there, Kyle. I know it's kind of a long question. I don't know if there was any other sort of follow-ups there.
No, I think we're good on that one. Nice job on that one. Trent, what about glide for 454B?
Yeah, so 454B is a blend, and blends do deal with glide at different temperatures. Not entirely different than what we dealt with 410A for many years. So I don't expect this to be a major consideration. It is something we also took into account whenever we designed these products and the coil selections and coil geometries and things like that. So yes, there's Glide for 454B. R32 is a pure refrigerant, not a blend, so it theoretically doesn't have it. But again, I don't see this being a material difference between what folks are used to dealing with on the R410A side.
All right, this one is from Brian. I'll send it over your way, Eddie. What type of maintenance is required for refrigerant detectors? How often is maintenance required?
Yeah, so the way the sensors are built, there's really no maintenance required on those. The sensors are advanced so that they are checking themselves, checking the status, ensuring they're operational. The unit will go into alarm and will not operate with a faulty sensor. So the only maintenance is in the unlikely event that this sensor fails for whatever reason, then it just needs to be replaced. But it's sort of a self-monitored sensor. No ongoing maintenance is required.
Eddie, one caveat I would add to that is that's true of our equipment, and other manufacturers have been pretty close to the vest because these are proprietary systems. And so I would say make sure to ask your manufacturer what their guidelines are. We designed our stuff to last for the life of the product.
Trent, is both Canada and Mexico required to phase out R410A by government regulations?
Yeah, that's a great question. I think a lot of people assume that other governments are going to change these laws at the same pace as the U.S., but the reality is every country has slightly different obligations under the Kigali Amendment and climate laws or climate agreements. And different countries have different ways of getting to those goals. So Canada, for example, has a lot of sustainable energy in their country. They got a lot of hydropower, a lot of wind, a lot of solar. And because of that, and because of the different parameters of the U.S. energy grid, one of the biggest levers in the U.S. that could be pulled to achieve climate commitments was this refrigerant phase down. It wasn't as urgent for Canada. Now, a lot of hard work has happened between trade associations, manufacturers, code officials, government officials. Since we share so much equipment between our markets and so much kind of moves together, ideally we unify our transition. So there's work that Eddie hinted at earlier about how the Canadian government's accelerating their review of their refrigerant laws. And we expect them ultimately to be unified relatively soon with the rough schedule that the U.S. is using. But as of now, there is no mandated transition in Canadian law to these new refrigerants. Since most of the manufacturers are U.S. based, however, and since we are currently prohibited from building R410A and exporting it, we need to make sure to reconcile that to ensure Canada has no interruption of supply of equipment. So I feel pretty good about this. If you'd asked me 3 months ago how we felt about this, I think Eddie and I would be sweating bullets because we didn't feel like there was a great solution in place. I think we're on the path to there not being a disruption for Canadian HVAC users and contractors.
All right, then also, Eddie, this was from Tim.
Anything you would say on that, Eddie? I don't want to try to miss any key points. Eddie's running for us on this strategy, so he knows a lot about it.
No, I think you've got it covered there, Trent.
Good.
So stick with you, Trent. This one's from Tim. Do you foresee any drop-ins similar to R22 for 410A?
Yeah, great question. Many of y'all know when R22 became scarce, people created and marketed what were called drop-in refrigerants. I think a different discussion would be how drop-in were they, but I'll leave that to the chemical and refrigerant guys. But we're not aware right now of any drop-in alternatives for R410A. A 15-year phase down is a long way to go. The one thing I would tell you is it's likely that any drop-in would also be a high GWP refrigerant, and therefore would be covered under the same phase-out restrictions and allocation restrictions. So I don't think we're going to see a dynamic where a miracle drop-in solution will come in to shore up the shortage of our 410A. I think what's most important is we've got to recapture refrigerant. We've got to get it to a qualified reclaimer so that reprocessed recycled refrigerant is available for us to service our existing customers. So it may happen. I'm not an expert on the chemical side, but as of right now, we should plan that we need to provide our own service gas through recapture and reclaim.
All right, then, Eddie, where is the refrigerant sensed and how is the refrigerant redirected?
Yeah, so that's a really good question, Kyle. I think every OEM it did some research specific to their cabinets, right? And so each cabinet, even within Lennox, we have different box sizes. And the way the air travels through each one of these boxes, through the heat exchanger, et cetera, is different among the Lennox boxes as well as different OEMs. And so the sensor is placed in the area where the equipment is most likely to have a larger pool of refrigerant in the event of a leak. And so if you look in the indoor area, typically that refrigerant is going to flow down. And so in pockets of the equipment where we expect a higher concentration of the refrigerant, that is where the sensor is placed. And so it's specific to the equipment, it's specific to the box size, specific to the OEM. And so that selection of where the sensor goes, and some units may have more than one sensor depending on the design. So it is within the cabinet, it is specific to the design of each one of those cabinets. Where does the air go? As explained during the mitigation sequence of operation, that refrigerant, the goal is to dissipate it into the space, or if the leak gets outside on the condenser side of the equipment, then it gets released into the environment to mitigate the potential for any ignition.
All right, then, Eddie, Stephanie also wants to know, will residential units have the flammability concern, or is that really just for larger units?
No, so yeah, so the short answer, yes. This applies to both residential and commercial equipment. Good question there. Everything we're covering here is around commercial equipment, but the same applies to split systems, residential split systems. More of the sort of the split system sell through and the component sell through apply to those split systems. But the A2L low GWP R454B refrigerant that Lennox has selected will go into residential split systems as well.
All right, we're getting close to the hour here, but Trent, I wanted to ask you this one. I thought it was interesting. For a split system, will the refrigerant lines need to have any shielding or new requirements?
So this may differ on a local basis, but generally speaking, no. There's no change to the type of line sets you have to use or how they're protected. I think the industry will develop best practices over time, but generally speaking, we don't want to downplay in any way the potential risk of mishandled A2L refrigerants. But generally speaking, the refrigerants are very stable. It's difficult to ignite them, like Eddie described. It's difficult to create a scenario where there's enough refrigerant concentration to create an ignition potential. So as of right now, there's no changes to line sets, for example.
All right, sounds good. That's all the time we have for questions, but I'm going to send it back to you guys. I think we have one more poll question to see how well we advance here in the last 60 minutes. Right, guys?
Absolutely. Right. Thank you, Kyle. So we've got one last one here, and it's a slide that we originally started. The change is coming. There are new refrigerants for the commercial HVAC industry, both, as mentioned, the residential industry as well. And so what I'd like to do is take this very same poll question, and on a scale from 1 to 5, how prepared are you to manage the HVAC refrigeration transition? So you take a few minutes here, a few seconds here to submit your answer. And with that, as we see the results here, we want to thank you so much for your time and for allowing us to walk through some of the changes coming up over the next few months. We're about 6 months away of this taking place, and our job as OEMs is to educate you. So thank you very much. Trent, any closing words or any parting words there?
No, I'm glad to see. It looks like the average has ooched up from about a 3 to about a 4. So not declaring victory yet, but I'm glad we could help provide some base level knowledge for you, answer a few of your pressing questions throughout the day. Our objective here was not to talk in depth about Lennox's plan or Lennox's strategy. It's just to be an educational resource for all of you. If there's anything we can do in order to be an assistance or a help to you in your company or planning your transition, we have some valuable guides that are available on our website. I think there's a screen we can bring up here that has a link to where you can download some additional information. And then reach out to your sales rep, reach out to us, send us a message. Our goal here is when we manage this, there's an incredibly rapid pace of change in our industry right now. And it's been that way for about 10 years, and it's going to continue to accelerate. So it's important to us that we make a smooth and orderly transition as an industry. And that's our objective at Lennox, is to be the best partner to you in navigating the change in the market. So that's all I've got. And thank you all for joining today. We really appreciate it.
Thank you.
If you have any additional questions or comments, you can certainly don't hesitate to click the email us button on the console. We appreciate your time and hope you found this webinar to be a valuable experience. And enjoy the rest of your day, everybody.